everybody, welcome to the world of atoms. In this video, we're gonna introduce you the lab of Professor Fabian Natterhe in the University of Zurich and various interesting research projects from our group. 5 months ago, the lab was an empty meadow where the cows lived happily. After 5 months of team hard work, we assembled the STM with cryogenic system and were able to run the STM at base temperature 1.5 Kelvin to study the surface of gold crystal at the atomic scale resolution. Here the STM is scanning the topography of gold 111 surface and the herringbone structure is quite visible. Oh, sorry, I haven't introduced myself. I'm a PhD student here. In my first year, I built this so-called IVS setup, International Vacuum Station, with second-hand components and homemade pieces, which allowed me to explore the recipe of growing oxide on a crystal surface with small lattice mismatch and characterize the superstructure by checking low-energy electron diffraction pattern. My next step is to upgrade IVS with a room temperature STM, which Kevin puts a lot of efforts. And now I'm glad to introduce you to my colleagues.
Hello, my name is Lorena and I'm currently performing my master thesis here in this group. I basically study surface spin systems with AFM and STM. Both of these systems use a probing tip which is brought close to the sample, such that their mutual separation amounts to a few atomic diameters. AFM senses the arising tip sample forces, and the basic principle here is that the tip is attached to a cantilever that oscillates at its resonance frequency. Tip sample forces then shift this resonance frequency, which we can detect and use to map surfaces. My project is now focused on using a combined AFM-STM system to apply voltage pulses at specific positions in the tip's oscillation cycle. The aim here is to study the tip's trajectory in more detail.
Hey everyone, my name is Bergsingen and I'm a PhD student in Group Natter. During the day I have to perform a variety of tasks including mechanical work from tightening screws to making a table, or soldering some electronic circuitry, and for scientific purposes later dipping it into liquid nitrogen and not necessarily feeling great about it. Specific to surface science, there are techniques that require to be performed before being able to observe atomic interactions, which includes bombarding the surface with argonides and heating up the material to annealing temperature. And when it works, it's possible to observe morphology of the materials at atomic levels such as gold atoms forming herringbone structure. It is also possible to observe electron waves on the surface, just like rocks thrown into a sea. My project revolves around developing a novel technique for investigation of band structure of materials using advanced hardware and developing Python scripts for instrumentation.
Okay, that's it, Alice. Hope you enjoy our video and don't forget to follow us on Twitter.